Hello, so I thought I would make just one more video for this PHET simulation. When you first open it up, you're going to get this screen. You want to come over to the Charts tab, make sure you have those position, velocity, and acceleration graphs on here. So when you log into the quiz, it will give you a few questions like this, where you have to match up the position and velocity and acceleration curves to one another. So when you see these questions, take this one piece at a time. So you have velocity is red, position is blue, and acceleration is green. So let's see if we can recreate one of these curves. So let's say this very first one here, this red velocity curve, the dashed line is the 0 point. So what this velocity curve is describing here is we're starting out below the dashed line, which means negative velocity. The moving man is moving to the left. And that motion is going to start with a large negative velocity and then slow down to a 0. Pay attention to where velocity goes through 0. These are turnaround points. So in the position, remember the position versus time curve, that slope is velocity. So wherever velocity goes through 0, that's where the position curve is going to flatten out. The slope will be 0 here where the velocity is 0. So we're moving to the left and slowing down, stopping. And after this, we have a positive velocity. So he would now be moving to the right. So increasing velocity, and then right here, the velocity slope changes. That means our acceleration is changing. We're going from a positive acceleration, which you can think of as a positive force pushing him to the right. And then right here, we're going to change the direction of that acceleration. So we go from a positive slope, positive acceleration that is going to change to a negative acceleration. So this would almost be like wind is blowing in the negative direction. So it's going to slow his velocity down. So he's going faster, and then it's like he's putting on the brakes. He's still traveling to the right, still going in the positive direction, but now he's slowing down. His velocity is slowing down, and here is another 0 point. So another turnaround point where he slows down, stops, no longer is traveling to the right, and now will be traveling to the left. So before you try and plug this into the simulation, think through the motion that this graph is trying to describe here. Okay, now I don't actually know the boundary conditions of where he's starting and stopping. I know that he starts out traveling to the left. I might as well just start this at 0, and I'm going to start him with a negative acceleration. So moving into the simulation here, I have it downloaded. To reproduce this velocity graph, maybe I'll tile my windows. If you ever want to tile your windows, there's a little window button on your keyboard, and you can use the arrow buttons to tile it left and right. So here we are, we're going to try and reproduce this red velocity curve. I'm going to set numbers in here rather than physically dragging this guy around. I'm going to just give him some initial starting conditions. So velocity, we're starting with a negative velocity. So I'm just going to change this to, I don't know, maybe -4 or something. So I'm not getting exactly the same curve, just the general trend. So I have my starting velocity, which is negative, and then the starting slope is my acceleration. Acceleration is the slope of velocity, and I have a positive slope. So let's go ahead and I'll make acceleration +3. So let's play this. So he's going negative and turning around and coming positive. So you can see it's not exactly the same as what I have over here, but I do have a positive sloped line. And that is, again, the green acceleration is describing the slope. So I have a positive slope. And for the position, you can see where I turn around is where the velocity goes through 0. So even though I'm going in the negative direction, stopping, turning around, and then coming in the positive direction, so my position is slowing down and speeding up, but that was all produced by a positive acceleration. Again, acceleration is not change in speed, it is change in velocity. Speed and velocity are two very different things. A vector versus a scalar property, those are very different. So think of acceleration in terms of unbalanced forces. Acceleration is created when the forces in the system are not balanced. So positive acceleration, you can think of maybe there's a wind that is blowing him in the positive direction. Okay, so now that I have the system paused, I see the slope in my velocity curve has changed. So for this changing slope, I'm then going to come into the simulation and change my acceleration. So instead of +3, I'll go ahead and make him -3. I'm not going to mess around with any of the other values. I'm only changing the acceleration here. And now I will play the simulation, and you'll see him continue forward and turn around. Okay, so now I have this triangular shaped velocity curve, and you can really see what that has been created from. So if I click the playback button, I can move this gray bar around in the simulation, and you can see the motion that is represented in these three graphs below. And again, these three graphs are really, really important. So you will see these, it's the starting point of calculus. So Sir Isaac Newton was one of the fathers of calculus. These graphs are used in your physics classes, mechanics classes, and you're looking at a lot more than just position, velocity, acceleration here. So position often is tied to potential energy of the system. So whether it's a spring moving around or MGH, a lot of times when you look at position, you're also looking at potential energy. When you look at velocity, you can also think of this as linear momentum, mv, kinetic energy, 1/2 mv squared. So it's giving you more than just velocity too. You're getting energy information here. And then as you look at acceleration, F equals ma, it's almost like looking at a graph of the unbalanced forces acting on the system. So to understand how systems progress and move, these three graphs have quite a lot of information on them. And the sooner you become intuitive and really pay attention to slopes of lines and areas under curves, the trick is to see a line on a graph and be able to visualize the motion that created that line. And it takes a lot of practice to be able to do that. And again, take this one small piece at a time. So don't try to visualize the entire graph at once. Just take that initial little section. So think through the slope, think through where the starting velocity is, and you don't have to exactly recreate it. So I don't have exactly the same slope here, but it's close enough that now I can go ahead and get through the rest of the quiz to figure out what those other two graphs should look like. Okay, hope that was helpful.